Metric space.
Hello and hi dear students of mathematics. In this lecture we are going to understand that what are metric spaces. Metric space is a combination of two things. First of the things is a space, and the second thing is a metric. Metric is usually denoted by D by many authors, and the space X is denoted by capital X in most of the texts. What is a space? A space is collection of points. It is a set. For example, it could be a set of real lines, real numbers, which is called a real line, or it could be the two-dimensional plane R2, or it could be a three-dimensional space R3, a space of real numbers, and it could be an n-dimensional space of real numbers, or it could be a complex plane, or an n-dimensional unitary space. This is also called unitary space, which is an n-dimensional complex space. Or the space X could be a set of all continuous functions on an interval, for example AB, which is a closed interval, or it could be a set of all discontinuous functions in this interval, or it could be a set of all differentiable function in the same interval, or it could be set of all integrable functions in this interval, or it could be a set of all converging sequences to some specific point, or it could be a set of all non-converging sequences. So I think that it is now quite clear to you that what is a space. Next, the important one is the metric, which is oftenly denoted by D. What is a metric? The metric D, denoted by D, the metric is a function, and since it is a function, so it must have a domain and a range. This function D, the function D is applied on the points of the space X, and it is applied not on a single point. It is applied on the ordered pairs of this space. This means that the domain is the Cartesian product of the space X with itself, or it means that D is applied on the ordered pairs of this space. For example, if x1 and x2 are the two members of the space, then D is applied on the ordered pair of these 2 points in X. Next, what is its range? range, range. Its range is the set of real numbers. This means that D is applied on the ordered pairs of X and it results in the values in real numbers. And it satisfies the 4 important properties, and these properties are called metric axioms. These are 4 axioms that must be satisfied by this metric. First, you need to understand that D is also called the distance function, since it is a function and it is called the distance function. Since D is a distance function and the distance function has to be always non-negative, the first axiom is called M1. It says that D is always greater than or equal to 0. It means it is non-negative. Non-negative, it must be definite and it must be real valued. The second axiom is called M2 axiom, and it says the distance between two of the points in the space is 0 if and only if these 2 points were identical. If these 2 points were identical, then the distance between these 2 points could be 0. For example, d of x1, x2, since it is a distance, it could be defined by the absolute value of x1 minus x2, because the distance is the difference of 2 points in a space, and we have to take the absolute value because it has to be positive or 0, non-negative. If x1 and x2 are identical, it means that we can replace x1, x2 by x1, and this comes out to be equal to 0. So it was an example. Next property is also an important one. It is called the symmetric property, or symmetric property says that d of x1 and x2 is equal to d of x2 x1. This means that by changing the order of the points, the distance is always the same. For example, the distance between 2 and the point 3 is equal to minus 1 absolute value is equal to 1 units. Similarly, if we interchange the order, then we get the same answer, 1. This is what meant by the symmetric property. Next is the M4 axiom, which is the most important one, and it is called the triangle inequality. we will have to take 3 points x1, x2 and x3 from the space capital X. This triangle property says that d of x1, x2 is always less than or equal to the distance of x1, x3 plus distance of x3, x2. What does this statement say? For this we will have to take this point, let this is x1 and the second one is x2 and the third one is x3. If we connect these 2 points by a straight line, x1 and x2 are connected by by a straight line, then it means that this straight line is the distance between x1 and x2 and it is denoted by d of x1, x2. Similarly, this line is denoted by d of x3, x2 since it is the distance between x3 and x2, and this line is denoted by d of x1, x3. Have a look at this. This is always less than the sum of these two. The sum of these two is greater than this one. Therefore, we wrote that d of x1, x2 is less than or equal to the sum of the distances between these 2 points, which are d of x1, x3 and d of x3, x2. Similarly, this could be also interpreted as this side, the distance of these 2 points is less than the sum of other 2 distances, or it could also be written as this distance is less than or equal to the sum of these 2 distances. I think that it is quite clear to you that what is meant by triangular property. If a metric satisfies all